All right, everybody, welcome back to Here for the Truth. I'm Joel Rafidi, got my co-host Erasmus with me. Um, Today we have a very interesting episode on a very polarizing topic, exploring mainstream cosmology versus alternate cosmology. We have Mark Gober returning, who's written 7 books previously. This is his 3rd time on this podcast, and his latest book is called An End to Upside Down Cosmology. And he's done pretty great research into this topic. It's a book that we've both read and found quite fascinating and has definitely shifted the way that we perceive things to certain degrees as well. We've had requests previously for people to, for us to have a conversation, bringing up this side of the argument, questioning the globe, questioning heliocentrism, questioning the shape of the earth. So here it is, and I think you guys are going to get a lot of value out of it. Right before we dive into the conversation with Mark, the next round of Rise Above the Herd will be open for enrollment on September 24th. So this is a 10-week program for you to step into deeper authenticity, for you to reach greater levels of fulfillment within all areas of your life, you to take an opportunity to be reflected upon and get really real with yourself about what is working, what isn't working, and ultimately how you can value your human experience on a greater level and unlock greater creative energy for you to just walk the path that is uniquely your own. This is something that we love to facilitate and coordinate. This will be our 11th time running this program. So if you're interested, you can head to riseabovetheherd.co. Before the 24th, you'll be able to join the waitlist. After the 24th, you'll be able to apply to join the program. We're taking a maximum of 12 students only for this round. You can check that out if you feel called. And also, I want to highlight our new test, the Real AF test, which we recently curated. So if you want to discover whether you're real AF or not, we'll put the link in the show notes. And this is a little quiz that you can fill out. And basically, again, get mirrored to yourself as to where you're really showing up authentically in your life and in what areas. Without any further ado, here is Mark Gober.
You are now listening to the Here for the Truth podcast, hosted by Joel Rafidi and Gerasimos.
Mark Gober is an award-winning author. His 7 books span the topics of consciousness, science, politics, economics, medicine, cosmology, and more. He's a Princeton graduate, a former investment banker, and a former partner at a Silicon Valley strategy firm. This is his 3rd time appearing on Here for the Truth. He first joined us on episode 133, and then later on 162, diving deep into ending upside down medicine. And he's got a new book out at the moment, An End to Upside Down Cosmology. So Mark, just to kick this one off, man, like what piqued your interest in this topic? Why did you decide to venture into this arena next?
Well, I can blame Gerasimos for this one, actually. So a lot of people had been asking me about cosmology and my thoughts on shape of the earth, what's in the sky. And I said, I haven't really looked into this topic. And I was at a conference called Confluence in April in Texas. And the topic came up a few times, including in a conversation with Gerasimos. And because it was basically like, well, why does it even matter? Why does it matter what the shape of Earth is? Why does it matter? These questions people are asking, how close the sun is and how big the sun is and the moon and all those things. And I didn't really have good answers for it because I hadn't looked into the topics. And then after that conference, I looked into it much more deeply and was looking at both sides of the argument. And I realized that the way I'll say it is there are misunderstandings on many sides of the debate. So I wanted to at least frame what the arguments are so that hopefully the issues can be resolved more harmoniously. And I, like with all the topics that I've written about, I got hooked on it, and here we are.
I love it, man. I love that you tackled a subject like this because it's kind of no man's land for a lot of people. You know what I mean? Where it's like, okay, cool, you can challenge consciousness and some things like that and talk about politics. And then, your last book, you ventured into challenging germ theory, which is like also kind of, a little bit more on the fringe. But then with this subject, you went after like, again, what is this? Where do we live? What is this place? And I know it's really controversial. And I know that people that do explore this subject get labeled flat earthers and get made fun of and all that. So like, just much respect for kind of tackling things in the way that you did. And I definitely enjoyed your book, and I'm looking forward to getting into it. I guess like to start off, because you covered multiple aspects of it, but there's this whole idea of heliocentrism versus geocentrism. So can you explore that subject, and then like a little bit of the history, and why, when there were two I guess hypotheses presented, that one won out over the other, and has been kind of the ruling model for a long time?
Yeah, let me give a little bit of context first, which is that when people talk about the debate of flat Earth, often it's just about the shape. But to me, there are layers of this debate regarding the question you just asked, Yerasimos, of where do we live? One is, what's our place in the cosmos, meaning relative to the other lights in the sky? Are we in this massive universe? And are we revolving around the sun, for example? That's one set of questions. And then the next one, which is related, is, well, what's the actual shape of Earth? And they're related, but there are some distinct issues to look at. So what you're asking is, what's our place relative to other lights in the sky? And this is an ancient debate of geocentrism, meaning Earth is at the center, versus heliocentrism, meaning the sun is at the center and Earth revolves around the sun. And most of us probably haven't even thought to ask questions about this, because we've been told a cosmology of Earth is revolving around the sun. We're in a solar system where there was a big bang 13.8 billion years ago that started all of this, that got us moving to where we are now. But what I didn't appreciate until I started researching this is that mainstream physicists like Albert Einstein, Stephen Hawking, and many others that I quote in my book will readily admit that based on the observations of lights in the sky, we cannot tell the difference between heliocentrism and geocentrism, meaning they are equivalent in a sense. And there has been a preference philosophically toward heliocentrism because of what's known as the Copernican principle. So basically, in the last 100 years, there has been a bias toward heliocentrism because there's an implication that Earth is not special, or that we do not occupy a special place in the cosmos within heliocentrism. We are just one planet revolving around the sun within one solar system out of many. And people like Stephen Hawking have said, we do this on principles of modesty. And Edwin Hubble, who was part of the expanding universe theory, talked about how it would be a horror and it would be intolerable for Earth to occupy a special place. And some would argue that's because if we occupy a special place in the cosmos, that might invoke religious beliefs like spirituality, or even the notion of God, that we were placed here. So I just want to start there, because people will say, well, it's just, we've obviously proven heliocentrism already. And here we have many physicists saying, look, just based on what we observe, we can't tell the difference. And we're being steered toward heliocentrism for philosophical reasons more than other reasons. And might I add, and I go into this in the book, there are a number of observations which actually point more closely toward geocentrism rather than heliocentrism.
What are those observations?
One is the cosmic microwave background, which is an accepted phenomenon in science. And actually, there have been awards given to it in the last, let's just say, many decades, where there is a background radiation theorized from the Big Bang 13.8 billion years ago. And this can be observed in a visual, which anyone can Google and look up the cosmic microwave background. You'll see a bunch of dots in kind of an oval shape. The issue for heliocentrism, according to the heliocentric skeptics, is that this cosmic microwave background should be homogeneous and isotropic. Isotropic means it should not have a preferred direction if Earth is not in a special place. Whereas there are these little anomalies in the cosmic microwave background where it's not homogeneous fully and it's not isotropic, meaning there does seem to be a preferred direction. And in fact, it seems to point to Earth, in short. And scientists have called this an axis of evil, which is interesting to use the word evil when referring to just scientific observations, because these anomalies, to some, would suggest actually that there is a preferred direction that we're seeing here, and it's pointing toward Earth. And that's just one. There are observations of quasars, other galactic observations, where astronomers and astrophysicists in different areas will say, actually, this data that we're seeing challenges the Copernican principle. It challenges the idea that Earth is not special. And actually, we're seeing stuff that points toward Earth.
Yeah. Just in regards to Stephen Hawking, like it's interesting, right? Because there's many people who believe that Stephen Hawking is a complete hoax from the beginning. I don't know if you've seen the videos of like from the 80s or 90s where like he's just mumbling mumbo jumbo. This is before all the technology. Then some guys, his translator, just translates these perfectly coherent sentences, which is ridiculous and impossible. So when I was reading that section, what came up for me was just like, what does Stephen Hawking's thoughts matter anyway? Because I don't think it's personally proven that this guy actually was legit.
Yeah, I think if it were just Stephen Hawking saying this, I would hear you, but there are many others. So Einstein, I'll give you a quote right now. Fred Hoyle in 1973, he said, "Let it be understood at the outset that it makes no difference from the point of view of describing planetary motion, whether we take the Earth or the Sun as the center of the solar system." And then another one from I. Bernard Cohen. He said, "There is no planetary observation by which we on Earth can prove that the Earth is moving in an orbit around the Sun." That's just two examples.
Like, so is your argument that, heliocentrism was kind of put in place for humans to feel as though they're not special on some level? And like one of the more conspiratorial reasons why we leant towards heliocentrism was to disconnect us from some kind of specialness?
Yeah, I mean, my position on all this stuff, I'm glad you mentioned that, Joel, is I really don't know.
Yeah.
I think, and I'm actually more interested in poking holes in the current model rather than coming up with a replacement or an alternative and say, this is the answer. So the example I give in my book, before I answer your question, Joel, is imagine we're taking a multiple choice test, the three of us together, and there's options A, B, C, and D. And I come to you guys and say, look, option A is not it. It's definitely not it. And you guys actually think option A is it. And I'm like, no, look, I've falsified A and I can walk you through for hours why that's the case. And then you say, all right, Mark, we understand your arguments. They're pretty good, but you've got to tell me if it's B, C, or D is the correct answer. And I'm like, well, I don't know because I haven't done the analysis yet. And that's a much bigger question. And you say, okay, well, if you can't tell me if it's B, C, or D, then we're going to go with A. And what I'm trying to do is counteract that psychological tendency to say, look, there's a lot here that our current model has a problem. And I can't explain to you exactly what the alternative is. I can't tell you exactly why this current model has been propagated in the way it has, because clearly it has for so many people to believe it so strongly. But what I am seeing is a reluctance to want to challenge it. So with that preface, Joel, I'll say one theory put forth is that we are so biased with heliocentrism because it creates in us a sense of not being special, and it creates a smallness in the population. Whereas if we thought we were at the center of something and that we were all more significant, perhaps we would be less compliant. And one of the reasons that I am somewhat drawn to the argument is that I've been making this similar argument with regard to the nature of consciousness. My first book, An End to Upside Down Thinking, is all about the idea that the brain does not produce consciousness, and more generally speaking, that consciousness doesn't come from the physical world. Because if we believed that consciousness is beyond the body and that we survive bodily death in terms of our mind, then perhaps we would think life is more meaningful and not just fully random. So this idea of the Copernican principle to make us seem like we're small and not special, it aligns with a lot of other perhaps psyops that we've seen elsewhere. Now, the mechanics of this, there's a documentary called Heliosorcery that goes into this. It talks about Copernicus and Galileo and Newton and Kepler even, that there's been a conspiracy for the last few hundred years to move us toward heliocentrism because it takes away God. I accept that as a hypothesis, but I can't prove it myself.
Yeah, got you. For me personally, it doesn't land as a source of impact. Like I can consider heliocentrism. I can consider that we're not the center of the universe, and I can still feel God, and I can still feel special, and I can still feel the Hermetic principle of as within, so without, and recognize all the expansiveness that potentially exists out there also exists within me. I don't know if on a collective level, if it's more so that, oh, we're not special, so people feel more diminished. I can't really speak into that. But for me, it's like, that doesn't impact me as an individual in that sense.
Yeah, I mean, I'd have to agree a little bit in that. And I know we've talked about this before, Mark, where I go like, listen, whatever the shape of the fucking planet is, whatever's out there, like my day to day isn't really impacted. And like, I don't know, I still don't know. I loved your book, but I still don't know. I don't have all the answers. And that's why I loved at the beginning of your book, you literally said that this book is for those who are comfortable with three important words, which is, I don't know. are there convincing arguments that the current model, there's flawed? And I love that element about your book, and I do, and it's got me thinking. I'm like, fuck, maybe the Earth is the center of the universe. But even for me moving there, it's like I still don't think I feel more special, But again, it might be an individual thing versus, like Joel said, a collective thing. Like I think if I were to come to the conclusion, again, this is me personally, that like everything we've been told is a lie regarding the shape of where we live and certain other realities of the universe, I don't know if it would, besides a level of like, oh, wow, that's so fascinating, that's interesting, I don't know if it really impacts me in a way where it's like, oh, now my day-to-day is going to be completely different. But again, that's my personal experience, and I'm sure, I know you share something differently with me. So yeah, I just wanted to throw that in there.
Yeah, I mean, I hear where you're coming from. I do wonder let's take a few steps back and talk like metaphysics. If it's true that we're part of some kind of interconnected consciousness, and that consciousness is the basis of reality, and it would take a whole episode to go through the evidence for that, but I've written about it, and you guys have talked about it too. But if we accept that to be true, then our physical reality is inherently malleable. Like that's just a logical next step of it. So if we have a collective consciousness that's steered toward a falsehood, I just wonder what that does to our reality. I don't know. But it might do more than we actually appreciate. Even if we say, look, I don't feel it on a day-to-day basis, but if we're living in a falsehood in terms of our place in the universe, let's say we do occupy a special place, that there has been some creator of some kind, some intelligence that created this place for some reason, and we're not just a tiny speck in this massive vacuum of space, an incomprehensibly big vacuum of space, expanding at 1,000,000 miles an hour out, free falling around the sun at over 60,000 miles an hour. Like that's what we're told is happening to us. And if we're living in a falsehood versus the geocentric, actually stationary Earth model, I don't know what that means. Now, there's a separate conversation too, because geocentrism versus heliocentrism also will lead into questions about Earth's shape. And if Earth's shape is not what we're told, there could be potentially resources that are being hidden, or even technologies and physics, like ether-related physics and free energy and things like that, which would affect our day-to-day, if any of that's true. And it does relate to heliocentrism versus geocentrism, because heliocentrism posits Earth's motion. And if we start to erode the beliefs in Earth's motion, that brings back the ether. And if we bring back the ether, which is the fifth element, and that was an ancient belief, then we might be getting into new technologies, which would affect our day-to-day, because there might be scarcity that we perceive now that actually doesn't exist.
Yeah. What are the, like, because I have to admit, it feels like we're not moving. Like living here, like everything that you've explained in the book, and that is the conventional kind of explanation. Like we're free falling through the galaxy, we're moving around the sun at 66,000 miles per hour, and all the other, the numbers around that. Like it just doesn't feel that way. When I look up, it feels like, oh, like that star, I kind of just see that there. It's there all the time. Like, what's the argument for people that, challenge this understanding, the geocentric understanding, or the flat Earth model, in terms of why that is? Why doesn't it feel like at all that we're moving?
Well, I haven't heard very compelling arguments. I mean, some would say that, well, you just don't feel it in the same way you get on an airplane, you don't really feel motion. That's not true. If there's any bump, you feel it. And if you're changing speeds, you feel it. So let me walk through the different types of motion that the heliocentric model posits currently. So that means you guys right now, and me and everyone watching and listening to this, you're moving in the following ways right now. The Earth is rotating on an axis, which is tilted at about 1,000 miles per hour at the equator. It's closer to 0 at the poles on the sphere. But at the equator, it's about 1,000 miles an hour, and that's faster than the speed of sound. But you don't feel any of that. And Earth has multiple wobbles on its axis, which we don't feel. It's revolving around the sun at over 66,000 miles per hour. It's actually free falling, and we don't feel it. And the pattern of motion is elliptical, meaning it's not constant. And that gets rid of many of the arguments I hear of, well, we have constant motion. We don't have constant motion because it's an elliptical orbit. Also, Earth revolves around the Milky Way galaxy at over 500,000 miles an hour and is moving through an expanding universe at over 1.3 million miles per hour. And we don't feel any of it, but we do feel an earthquake. But think about this. If there were any change in motion of any of those things I said, like how could a surgeon perform surgeries accurately without having to worry about like making a mistake and killing someone, or playing a game of Jenga, or having a big rock exposition, which we've seen, where you have these rocks stacked up on each other. If anything were moving, things would fall. So there are lots of examples like that where it does seem like we're stationary, and we're told, well, your senses are wrong, and physics tells us otherwise because of X, Y, and Z. And we could get into the problems of physics too, because that's really critical to it. But just based on our common sense, we feel pure stationariness.
I mean, like observable reality. I mean, I like if no one ever told me a theory or a hypothesis and they asked me here and now, consciousness blind to whatever potential cosmology exists, Joel, do you think that, whatever you're currently living on is moving? Like, my answer would obviously be no, right?
I mean, I'd have to agree.
How could you? How could you assume that you're moving in all these different ways, without that?
Yeah.
We've had arguments. We've had arguments on the show before that, like, if you were in a car and you moved 1 degree every day for 365 days, would you feel it? And obviously
Maybe.
You wouldn't. Yeah. You're in a car for a whole year. You're moving 1 degree a day.
Yeah, but what would be the speed, and would the speed be changing in terms of how I'm moving? I don't know.
Right. And any little bumps? I mean, in a car at 5 miles an hour, you feel bumps.
Yeah. And again, like, I don't know. There's so many like unanswered questions. And this brings up another point, because there are people that will argue like, well, you can't just scrap a current hypothesis unless you present an alternative one. Whereas I think there are people that are presenting alternative ones. It's just a matter of who thinks they're more right than the other.
Well, let's flip this. What are the holes in geocentrism?
What would you say they are? I mean, I don't.
You're the one that's done the research, right?
Yeah, but I haven't found any good ones, because they're okay. All the physicists are saying, look at the sky. It's either way.
Okay.
I mean, and we've basically just chosen one over the other and retrofitted all the observations.
Can we go back a little bit? Can you talk? I mean,
some might say like it's more elegant. Yeah, go ahead.
Sorry, I think there's a little bit of a delay.
There's a bit of a delay. Yeah.
Delay. So we might have to like wait until a person's finished talking. Keep going, and then I'll I'll say my point.
Yeah, I would say I when I look at all the data together, everything can be explained with geocentrism. And there just seems to be this preference of, no, it seems heliocentrism works better. I mean, I'm not going to just restate the book, but I go through example after example of all the galactic observations that fit geocentrism well. It's just, there's an aversion that many of us have of like, no, that's an ancient belief system. That means there's a creator. But you can explain stuff with geocentrism.
Yeah, well, that's the one thing I liked about your book, is that, like, of course, over the last however many years, you hear a lot about like flat Earth or not flat Earth, but like the way you go into geocentrism versus heliocentrism, getting into the history of it, and then bringing up these other thinkers that have challenged it. I never heard of some of these people, that have been challenging, in terms of like our place in the so-called universe. But again, like what I was saying before when I cut you off because of this little delay, can we go back a little bit in terms of like even like the mainstream consensus thought on what is the universe? Like, what is the Big Bang? Like you mentioned,
I think dark matter needs to be a conversation.
You mentioned dark matter and dark energy in terms of how that supposedly, scientists are saying, oh yeah, it makes up 96% of whatever the universe, but we don't really fucking know what it is. Like, can you talk about that?
Yeah, this is a big one for me, because it's like, it seems like physics is a house of cards when we look at dark matter and dark energy. Dark matter and dark energy, if you talk to mainstream physicists, that comprises 96% of the universe. And 4% of the universe then is observable matter that we know what it is. And why did they have to come up with that? Because starting in 1933, an astronomer, Fritz Zwicky, was observing the Coma cluster of galaxies. And basically, they were moving much more quickly than would have been expected based on the laws of physics, specifically the laws of gravity as described by Albert Einstein's general relativity theory. So these are fundamental laws that underlie like everything, gravity and relativity. And the observations were not matching up. But it's not that they were off by a little bit. There should have been 400 times as much matter present in order to explain his observations, meaning that the observable matter accounted for less than 1% of the total mass that was required to be there. So they got it totally wrong when he made these galactic observations. So what did they say? They said, well, there must be matter there that we can't understand, we don't understand, that we don't observe, and we're going to call that dark matter. So they discovered dark matter. Instead of saying, we just found that relativity and gravity are problematic, we have discovered something new. And the problem is scientists still don't know what it is. And I quote a mainstream astrophysicist in my book, Pavel Krupa. He and his colleagues at the University of Bonn in Germany have falsified dark matter now with more than 5 sigma confidence, which means more than 99.999% confidence. They're observing things galactically that don't match the predictions of dark matter. And he basically says the only reason we're still studying dark matter is because of sociological pressures, that you can win prizes and things like that if you stick with this narrative. Now, why would it be problematic if dark matter didn't actually exist? Then we would have to rethink basically all of motion, because gravity is how we think about how things move, especially galactic observations when we're talking about heliocentrism versus geocentrism. But even as simple as, an apple falls to the ground, we know it falls to the ground because we see it happen over and over again. The question is it falling because of a force called gravity, meaning that there's some force within mass itself, within the Earth, because it has a bigger mass than the apple, that attracts the apple downward. And the theory of gravity, which came from Newton, is objectively not workable fully, meaning it cannot explain all observations. Even things like Mercury's motion, Newton's laws of gravity can't explain it. So Einstein's relativity has come in to basically supplant the flaws of gravity. And Einstein talks about a bending of space-time, but even relativity has problems. And I quote a physicist named Robert Bennett, who works actually in a lineage of people who studied relativity, including he himself, where the special and general relativity theories, one is a subset of the other, they don't even match up. So there are all kinds of problems with relativity as well. And then we throw in the dark matter problem, which is trying to keep those things up, to prop up gravity and relativity, and it is having problems and arguably is falsified. So then we run into real issues of having to rethink physics from scratch, which then relates to Earth's motion, our place in the cosmos, its shape, all those things are related to it.
Yeah. You mentioned a term often in your book, a post hoc rationalization. Would this fall under that? Or they're like, oh, well, we can't really explain it, so let's create something or come up with some formulas that explain the thing that we can't explain?
Yes. This is a post hoc rationalization where we've observed something and then we're going to rationalize it and say, well, we discovered dark matter. Another example I mentioned in the book is a particle that's theoretical. It's called an inflaton. It's a particle that would be needed to explain the expanding universe that came from the Big Bang 13.8 billion years ago. But no one knows what that is. It's completely hypothetical, but it would need to be there basically to explain how the universe started under the current heliocentric model. And what happens, and we see this also with germ theory and the whole virus debate, which we talked about last time, it's known as the reification fallacy, where you refer to something as if it exists, and then you reinforce the belief that it's there. So you say, oh, well, dark matter, dark energy, inflaton, as if they exist, but actually they're hypothetical. So we should always be saying alleged dark matter, alleged dark energy, alleged inflaton, alleged virus, for example. All these things have flaws in their fundamentals.
So what I'm curious about, you mentioned the physicist of the 1933s, studying a cluster of galaxies. We've seen these pictures online, all those little galaxies, with the telescopes. Do they exist? Are these just hypotheses? What was he studying? Are there clusters of galaxies? What is space? Well, I just so many more questions to ask.
Yeah, I mean, me too. I would say most people can agree that there are lights we see in the sky and we have telescopes and we can observe them. Question is, what are those lights? Are they light years away or are they much closer? Those are the big questions. I don't feel like I have good answers to them, but I do think we observe stuff. And how we interpret those observations is what leads us to these various models.
Yeah. Well, speaking of observation, last night, I don't know if we have a full moon going on, but I was driving on our road and the moon was just so bright and so distinct. And it felt like I could reach out and touch it. And yet, we're told it's how many million miles away or thousands of miles away. And so I'm curious if you can maybe talk a little bit about that, unless there's something else you want to touch upon first. Again.
Yeah, this is a big one. common sense stuff here that are reasonable questions to ask. We're told that the moon is 238,000 miles away, roughly, and the sun is about 93 million miles away. And yet when we have an eclipse, in spite of the variations in their distance and their sizes, they look perfectly aligned so that one goes in front of the other. It just happens to be that their sizes and distances match up so that you have eclipses like that. These are, I think, reasonable questions to ask. You can look at the moon and you can see granularity from the ground, or you can even see that the moon seems to light up some clouds and then not other ones around it, almost like it's a flashlight that's localized. Whereas if it were really far away, you might expect more dispersion in the light that's going out farther. Yeah. So these are questions that seem reasonable to ask. The problem is people would say, well, no, we have a very specific cosmological model that's based on the laws of gravity. It's all specific. If the laws of gravity and relativity are true, where the size and the amount of mass and the distances and their speeds, it's all in conjunction, basically. It's all moving in harmony based on those laws. So if you believe those laws are true, then the moon has to be a certain distance. It has to have a certain mass. The sun has to be a certain distance away. It has to have a certain mass. You can't affect those variables because then everything changes in the whole cosmology. So I'm glad we started with talking about dark matter and gravity and relativity, that those have problems. And that's why I started the book that way before getting into flat Earth, quote unquote, because how can you even begin to question the size and distance of the sun and moon if you believe in gravity? Just your head explodes. But when you realize, wait, gravity and relativity are not what we've been told exactly, and even mainstream physicists will point to the problems. Maybe if there are different forces at play, okay, maybe we should trust our senses. Earth, could it be stationary? Maybe. Could the lights in the sky be closer than we're told? Okay, possibly.
Fascinating.
Yeah, definitely fascinating. So I've got a question. So like we see like Elon Musk investing in space technology. We see Jeff Bezos investing heavily in space technology, and like, you know, so like, is this all just a farce? Are they all just like in on it, and there's like nothing, they know there's nothing to explore? But that doesn't make sense to me, you know, from a simple like rational capitalist perspective. I don't think that, you know, they're going to just pour money into something purely to upkeep an illusion for, you know, whatever powers that potentially be. What are your thoughts on all that?
My thoughts here are just going to be speculative because I don't know these individuals personally. I don't know what their motives are. But look, we've all grown up with a certain model of how space works. And it's understandable to say, look, if I have a lot of money, I want to explore the outer worlds. So conceptually, it makes sense to want to invest in that. And I do think rockets are sent up in the sky. The question is, what's going on there? I mean, where's the continuous footage as it's ascending? A lot of people criticize that because you would expect. So now we're getting into flat Earth debates of the horizon rising to eye level as we ascend, whereas if Earth is a sphere, we'd expect if we saw continuous footage going up and up and up, there would be a down and away bend based on the radius value of Earth that you could calculate, but we don't see that continuous footage. So people criticize that. And then there are lots of anomalies we see, and I have a whole chapter on this, chapter 6 of the book on space agencies, NASA, the ISS, strange anomalies where they told us something and clearly it's not true. So like footage on the ISS where there are things floating, and anyone can watch these. I cite the YouTube videos in my book. One thing's floating, another thing falls. Like that shouldn't be happening. So to me, when there are any of these anomalies regarding space exploration, it gives reason to then question the narratives that we're told everywhere, whether it's in the private sector, which is emerging now, but especially in the public sector, NASA and other countries around the world in their explorations.
Yeah, got you. So like previously to going on this.
And can I add one thing, Joel?
Please.
Yeah, before you go on, all the space agency narrative is based on very specific beliefs about gravity and relativity and the vacuum of space. And I haven't gotten to the vacuum of space. This is a big one because when you think about how just basic pressure works in physics, if you open a can of soda has higher pressure inside relative to the outside. You open the can, it makes a loud noise because the high pressure from inside the can, it diffuses out. It equalizes basically to the lower pressure area. That's just a microcosm. Now imagine the current model of space, which is that there is a nearly infinite vacuum outside Earth meaning an extremely low pressure system, whereas Earth has gas that stays down in it. But we're told that this system of Earth is existing next to the vacuum without the gas equalizing to the low pressure system like it does when you open up a can of soda. The air from Earth is not rushing out into the vacuum. But we don't have a closed system. So if you have a can of soda, it's closed off from the outside until you open it up. And then the gas diffuses out to equalize, to reach an equilibrium. We don't have that. We're told that we have Earth's atmosphere peacefully coexisting right next to a vacuum because gravity is holding it in against this immense pressure gradient that you would expect. So many people are questioning this, including Stephen Young, who wrote a book called A Fool's Wisdom. He has the PhD in theoretical physics, and he's saying the same thing, and a lot of other people saying this too. And I bring this up in the context of your question because we're talking about space exploration. What's implied in all that is the vacuum of space in an open system where there's nothing enclosing us, that our atmosphere peacefully coexists next to the vacuum of space. And for some reason, it's allowed to happen that way. But if that narrative is not actually true because it violates basic ideas of physics, then it makes one naturally question the space narrative, because the space narrative is based on a very specific cosmology of gravity and relativity and a Big Bang, heliocentrism, vacuum next to our atmosphere, and so forth.
This is where, the argument where people say there's like a firmament that's making Earth a closed space comes into play. Like that's what's preventing us from just getting sucked out into the vacuum of so-called space.
Some people say that. I haven't been there, I haven't seen it. But a closed system would make sense if there were a vacuum. But then some people would say there's no vacuum at all. They would go to the biblical texts, which talk about the waters above and the waters below. And they'd say, yeah, there's a firmament, but it's not a vacuum above us. It's some kind of fluid medium. And there was a film done by Crow 777 Radio, the host of the show. It's a documentary that shows his filming of the moon and actually other celestial bodies, where it looks like, he calls it a lunar wave, where it looks like there's a fluid-like medium that you can actually see when you look at the moon through a telescope, and you can see it, I believe, with Jupiter too. So who knows? We haven't been there, but maybe it's not even a vacuum of space. Maybe that the bodies we see in the sky are somehow within a fluid medium.
Do you believe that we are like even in space at all? Like, is it potential that we're just like on the ground and like we're not even like floating in quote unquote whatever it might be?
Yeah, I mean, I'm open to it. Like, think about the model that we're told. We're literally on a ball that's just floating in this infinite vacuum and then doing all the motions that I mentioned, free falling around the sun and so forth. Like, it's so counterintuitive versus what does it feel like? Maybe like this is it. I don't know. Like, this is it. And then there's stuff that moves around us, and the sun looks like it's moving around us, and everything else is moving around. You could say Polaris, the North Star. And maybe that's it. The problem, Joel, is that there's a lot that we have not and cannot observe currently. Mm-hmm. So I don't think we can have a model of what, to answer your question.
Yeah, like
all we know is the
Go. There's delay. It's all right.
Okay, I'm going to try to answer what I think you were going to ask, which is we've only dug down under 8 miles deep. Whereas the radius value of Earth is supposed to be about 4,000 miles. So like if we're on a sphere, we should be able to dig all the way down, right? To dig down to the core, this molten core that's supposed to be so hot, which by the way generates the magnetic field, and there are problems with that, which we should discuss later. But we've never been to the core. And there were all kinds of problems in this expedition that I talk about in the book when they were trying to dig down and they got under 8 miles. And the reason that, their predictions were wrong. So we don't really know what's below us. And we would need to know that in order to answer your question, Joel. We'd also need to be able to have lots of independent verification of things from above, ideally from way far out. So what would be ideal is if we would have some probe just take 24-hour continuous footage of Earth spinning on its axis, where we could see every geography in continuous footage, not stop and start. We could see the buildings standing up straight on top, sideways on the side, and upside down on the bottom, which is what we're told is happening currently. The ocean's being held on by gravity, and we see every geographic location. And furthermore, we could see Earth's location in the solar system. So we could see Earth, we could see all the other planets in alignment, we'd see sun at the center. Where's that image? So we're lacking that data from above. And then we're lacking data from within Earth itself because there are restrictions imposed by governments in terms of where we can go. So there are some restrictions in the Arctic area, in the North Pole, but the biggest one is Antarctica. The Antarctic Treaty of 1959 essentially prohibited free travel to the Antarctic region. And certainly people go to certain parts of it, but we haven't freely and privately explored the full thing. And sometimes they say, it has to do with environmental restrictions, and it's much harder to go there than people would suspect. That was one of the big awakenings for me when I researched this, that past the 60th south latitude, all these restrictions kick in, and you have countries that, like the US and the Soviet Union, they were supposed to be enemies, and they were signing this treaty together. So like, why are the countries of the world that seem to be fighting off and they're all agreeing to restrict access? This doesn't prove flat Earth on its own, but it raises questions about where we are, and it makes it impossible to give an answer to your question, Joel, which is a really valid one. We can't answer it.
Yep. You've previously explored the topic of ufology and aliens and stuff like that. How does, I guess, this new research that you've dove into shift what you think about ufology and aliens? And like, if we're saying that Earth is the center of the universe and we're the special place, then what if there is aliens that exist interdimensional, or within quote unquote space or extraneous to Earth? Then what are we saying, like they're not special,
Yeah, great question, because I've had to rethink a lot. I wrote a book called An End to Upside Down Contact. It was published in 2022, all about contact with non-human intelligence. And often those intelligences they're talking about coming from vast distances away, like coming from other galaxies. I would say I still do think there are other intelligences, because often the contact is multidimensional. But I do think there are weird anomalies with actual crafts. The question is, where do those crafts come from? So I'll give two different hypotheses. One is that maybe the lights that we see in the sky, maybe they're more local. There aren't these vast distances away, but they represent locations that you can metaphysically travel to. And in my book, I quoted Emanuel Swedenborg, who's a mystic from several hundred years ago, who talked about being taken in his consciousness to other planets, meaning his body stayed here, but somehow he went there metaphysically. So maybe there are other worlds in the sky, that those lights in the sky represent other dimensions or something where you could exist. And maybe some of the crafts are able to travel multidimensionally in that way. Just a hypothesis. Another is that, let's say there are lands beyond what we know of as Earth, where there are hidden resources and maybe even other civilizations. And those civilizations could be other species of beings. They could be humans. And in the book, I mentioned a few alleged encounters beyond the Antarctic ice wall. So they claim. We can't validate that. But there's a lot of talk that there could be other life well beyond what we've explored within Earth. So that could explain contact as well, that there could be advanced intelligences there too. But I don't know the answer.
There's wildlings, beyond the ice wall. I feel like I wonder if like
White Walkers.
The White Walkers, like Game of Thrones was like a form of disclosure or something. Anyways,
who knows?
Very, very, it's all obviously incredibly interesting to contemplate. And, I lean towards, like, there's shit on the ground which quote unquote scientists get wrong all the time. There's, even on a microscopic level, we talk about virus and germ theory, et cetera, et cetera. How can they possibly conclude all this vast, super technical stuff? It's supposedly, so far from us. So there's no doubt that, once you go onto this exploration, there has to be at least question marks, like for sure.
And again, are you willing to ask the questions? Can you sit in uncertainty? Can you sit in I don't know? Can someone pick up your book, read through it, someone who's highly dogmatic in their belief system, and then deal with whatever comes up in them? And then to go, oh man, like this is interesting. Like, fuck, it takes a certain kind of person to challenge their belief systems to that degree. But then if you throw on top of it your entire career and your livelihood and your education, I mean, again, we go through indoctrination centers to some degree, based on academia. And so like to unlearn and relearn when your whole life is based on something and your whole identity is, it's like, again, it's it's a rare individual that does that. But I'm fascinated by it. This isn't an area that I've really delved deep into, and we've talked about this. I had no reason to not think, oh, well, the sphere. I mean, the sphere is almost a perfect shape. It would make sense that Earth is a sphere. But you bring up points that make me go, well, let me sit more, and I don't know, and I'm curious, and let's see, what this is. That being said, and I want to get more into some of the supposed holes in the spinning globe model that some people that are globe skeptics bring up. Actually, you know what? Let's go there first, and then we can talk about this supposed experiment that's happening soon. But can we talk about that as someone who I would assume is a globe skeptic? Would you, is that accurate to say that you are a globe skeptic?
I would say I'm a globe skeptic, yes, because there are too many holes just from what we've talked about so far in the physics, without even getting into what we're going to say now. But keep going.
Well, no, I think, yeah. Okay, you answer that question. Like, what makes you a globe skeptic? From the challenging the spinning globe model. I know we've talked about a bunch of different things, but what are some of the things that so-called flat earthers bring up to go, listen, we're not on a spinning globe, or we're just not on a globe? Forget the spinning part.
Well, let me rattle off a few. Yeah. Okay. Well, on the spinning part, I do want to just say a few things quickly. So I mentioned cosmic microwave background before. I mentioned other galactic observations, quasars, other types of observations like that. Also, the Michelson-Morley experiment of 1887 and the quote-unquote Aries failure that was also in the 1800s, which arguably have been misinterpreted. And because of that, we have preserved the belief that Earth moves. So that I would just reference that for your audience, because this gets into technical physics stuff, which basically Albert Einstein had to, some would say, cover up for those 1800s results with relativity theory, which has problems, which we're now seeing with dark matter. But all that stuff does matter because gravity is relevant to our beliefs about Earth. And I've heard some people say, well, you couldn't have a flat Earth because then it would collapse in on itself due to the force of gravity. And you see how that could be circular reasoning, because you presuppose that gravity is what we think it is. Whereas maybe there's some other reason that objects fall. So that's an important preface, because you need to have that foundational understanding. Otherwise, people will say, well, I'm not even going to talk about flat Earth. With regard to the shape of Earth itself, what I try to do in the book is go through quickly some of the top examples that people bring up. One is seeing things that are too far away based on what the globe model asserts. So the globe model asserts a radius value of this sphere. More specifically, it's an oblate spheroid, according to the physicists, meaning it's not perfectly spherical, but basically a sphere with this radius value of almost 4,000 miles. That means you should be able to calculate what you can see at a certain distance away. And there are debates about the calculations, but this is one of the arguments that globe skeptics make, which they take out a telescope or binoculars or something, or they calculate what they should be able to see based on their elevation, and they see things that should be blocked by curvature, meaning it would be like trying to see something that's around a physical bend. You can't see it because it's around the bend. This is the same thing. Something should be below the curve. And what people say is repeatedly, they do their own experiments and they're not seeing that. That can be debated, but that's the big argument that we hear. And go ahead.
And I was saying, so when these arguments are brought up, what's the counter argument, or the so-called debunking of the flat earther, around this, the line of sight thing?
They say refraction, meaning the light bends, and what you're seeing is a mirage.
What does that mean?
Some would say that.
What does that mean?
That the light is literally bending. So what you're seeing with your eyes there is not a building, because it's impossible that a building would be there, because it should be blocked by curvature, they'd say. And you're seeing somehow the light is bending. So it is below the curve, but it's not actually there. And I'll give an example since we're talking about refraction. Another related example, it's the Selenelian lunar eclipse. This is an acknowledged type of eclipse. And I quoted a science website that says, well, it seems impossible, because what happens during this eclipse is that the eclipsed moon and the sun are visible above the horizon at the same time. Why is this problematic? Because under the globe model, the Earth should be in between the sun and the moon, causing the shadow. So you shouldn't be able to see the eclipsed moon and the sun at the same time. So what do they say as the explanation? Refraction. That you're literally seeing an illusion. It's not there. Both are below the horizon. and it's just a mirage. That's the explanation.
And going back to what you said, I still think it's fascinating that like, the sun is 400 times farther away and also 400 times the size of the moon. It's for them to line up perfectly. I'm not saying it's not possible, but it's interesting to think about.
I remember reading once for one of the eclipses that we experienced on a flat Earth model, there would have to be like a third object in the sky, right? That would be causing it.
Okay, that's a good point, Joel. So what I was just doing was saying the problems with the current heliocentric spherical model in terms of explaining the eclipse, but that doesn't explain the eclipse on its own.
Yeah.
And there are different theories about this, and some say that there are other bodies in the sky where we don't see them with our eyes ordinarily, but they have an ability to block light. So they're there, so we see their effect by getting in the way of the light in the sky. And some say this is related to like Vedic astrology. They talk about, in Vedic mythology, they talk about Rahu and Ketu, which are these beings that like eat the sun, and that even in Vedic astrology, I believe that these entities are described. So there could be other bodies in the sky that our eyes just don't perceive, and that could explain eclipses. That's one explanation, but of course it's hypothetical at this point.
Mm-hmm.
Can you talk more about?
So should I go through a few more?
Yeah, go through a few more.
Yeah. Okay. So I mentioned basically seeing things that are too far away. There are also mirror flashes that have been done where the light comes in on a mirror from the sun, and it should be only reflect a certain distance away based on the curvature of Earth. Meaning you should be able to see that mirror flash at only certain locations. Otherwise, you're below the curve. But people can see them allegedly when they've done these experiments at locations that don't make sense. Also, people sometimes point to horizontal wave propagation, meaning you send out waves horizontally and they should fly off Earth, but they somehow reach another person using like just basic communications. Like you can reach someone on a part of the sphere, the alleged sphere, that where those waves should just be flying off horizontally. And the explanation is, well, there's an ionosphere and the waves deflect off of the ionosphere and then get to you, even if you're below the curve. The problem is that researchers like Austin Whitsitt, for example, who's done a lot of work on this, find that at certain wavelengths, the ionosphere would not be able to, the alleged ionosphere would not be able to reflect those waves such that they reach someone below the curve, and yet they somehow reach the person below the curve. The explanation alternatively would be that Earth is actually just flat up to that point, at least, and it's easy to explain horizontal wave propagation because it's just horizontal. And in the book, I also reference whale communication. So whales in the sea are able to communicate at vast distances, and you can't invoke an ionosphere in the water just to say that why they could communicate over such vast distances. So scientists have said, well, there's a channel, and the communication between the whales, these waves travel in some kind of a band around the sphere of the Earth. That's the post hoc rationalization. Whereas it would be much easier to explain by saying Earth is actually flat, at least up to a certain point, and the whales are communicating with those waves just on a horizontal plane. Yeah. I'll give one more and then I'll pause.
What is the distance that whales can communicate?
It's, I believe, up to 10,000 miles.
And on a globe Earth model, it should be a maximum of.
Well, I don't know what the exact calculation would be there, because
like if we're saying it's a 4,000,
I think, on
if we're saying it's a 4,000 mile radius or whatever, is that here? Sorry, what?
Yeah. For a roughly 4,000 mile radius.
Yeah. So basically, what we're saying, is that like these signals that the whales are sending out would miss the other whale completely. If there was that curvature that was there.
Right. That it would fly out into space, basically. It would fly out the water into space because it's the waves are being sent horizontally from one whale to the other, and somehow it bends around the globe, is what they're saying, mainstream scientists.
Yeah.
What do like
the distances are too far based on the radius.
Yeah.
I think this relates also to like engineers and what am I thinking of? Like snipers and all these other people.
The Coriolis effect.
Yeah, like can you talk about that too? Like, these other professions and these other industries that they're not taking into account, supposedly, again, curvature in order to like make their calculations.
Yeah. So in the book, I give a number of quotes from NASA papers, Army research labs, where they're always talking about the experiments they do over a flat, non-rotating Earth, and just quote after quote. So what people would say is, well, because they're just making approximations and it's close enough, and therefore this doesn't prove flat Earth. And I would agree, it doesn't prove flat Earth, but it is curious that engineers who should be doing things scientifically and tend to be pretty meticulous are using these assumptions of flat, non-rotating Earths.
Yeah. Can an argument be that like the Earth is just a lot bigger than we think it is, and that the calculations are wrong in terms of being able to see things in distance?
Yeah. So being able to see things farther than would be expected on the current globe model, which has a radius value of roughly 4,000 miles, all it tells us is that we can see that far. Therefore, it's flat up to that point, or at least it's a topographical plane would be a better way to say it, meaning there are peaks and valleys, but it's a plane up to that point. It could be a much more massive sphere. I guess that's theoretically possible. We'd have to go all the way out to know what the edges are. But think about it from the perspective of mainstream physics. If it's a much bigger sphere, then all of cosmology is in big trouble, because then Earth has a different mass. And if Earth has a different mass because it has a different radius, then that messes up all the gravity calculations. It messes up the day-night cycles. Everything is dependent on that radius value.
Yeah. Speaking of day-night cycles, can you talk about, and I know you were going to probably give some other points, but I think this may be related, but can you talk about like sunrises and sunsets? Because like, it looks like the sun is rising, you know, and then it looks like it's setting and it disappears. So can you talk about that?
Yeah, it's a super important point because it gets to the way that we see, basically the way our visual perception works in our biology. We have what's known as an azimuthal grid of vision, meaning that we see in curved visual space. And I'll give you an example, then I'll tie it to your question about the sunset. If you look down a straight road and you see lights on the road, they're all the same height, those street lights. But the way it looks from our visual perspective is that the lights are going down. They're the same height.
As they go farther away.
As they go farther away, they look like they're going down. Same thing happens with the railroad track, for example. These are parallel lines on a railroad, and let's say it's just a straight railroad track. It looks to us as if the sides of the railroad are converging. They're moving diagonally, basically to a vanishing point. But they're not. So our vision is basically interpreting things differently. And as it pertains to things in the sky, things that are above us, basically as they're farther away, they look like they're moving downward. But
wouldn't the railroads, like they look like they're getting smaller and smaller and smaller, and like, unless I'm wrong, when I see the sun at 12 noon up top and like the shape of it, and then when the sunset happens, I don't feel like it's like that much smaller.
I'm trying to think about this. I think first of all, there are issues with atmospheric refraction. So the atmosphere distorts what we see. And that's why there's weird things with like the colors and
gotcha.
There's stuff in the atmosphere that can distort the way we're perceiving it, in addition to what's known as visual perspective that I'm describing, where things in the distance look like they're getting smaller. So under under visual perspective, something directly ahead of you would look like it's the highest. But then as you look further away in the distance, it does get relatively smaller. Now, how much smaller, I guess, depends on all these other factors too. But you end up seeing in a dome of vision. It looks like there's a dome. So if you look out in the world, you have an ability to see in 360 degrees. And I was actually just in the Netherlands doing a book tour for two of my books have been translated into Dutch, and it's very flat there. So you have driving on the road, you can see this dome very clearly, where it looks like the clouds almost are setting in the distance because they look like they're so much lower around you. But in reality, everything could be, and likely is, just the same height above us, and we're perceiving this dome. So think about the sunset. It looks like the sun is setting. Well, first of all, it does look like the sun is moving from a geocentric stationary perspective. The sun is moving around us. And it's interesting that we call it sunset. The sun is moving relative to us. That's how our language perceives it. But it's actually moving outside of our visual perspective. And the other point I didn't mention is that we cannot see forever. So some people would say, well, if you're on a flat plane, then you should be able to see it. But if our eyes actually cannot see things forever, just like shining a flashlight in an atmosphere where there's a lot of fog, it actually disrupts the light. So you can't see it quite as much. So the idea under the quote unquote flat earth perspective is that the sun is moving above us. It's much smaller and much closer than we're told under the heliocentric model. And as it moves above us, due to visual perspective and atmospheric effects and the fact that we can't see light forever, it looks like it's setting, but it's actually just moving far away.
Yeah, it's interesting to consider.
So can you give us a basic outline of what the, traditionally accepted flat Earth map looks like and what the sun, rotations look like?
Yeah, good point, Joel. So I want to preface this by saying for all the reasons we discussed earlier, it's impossible to come up with a perfect map. So anyone who has a map, it's going to be flawed until we have full freedom of observation below us, above us, and within Earth. So this is an approximation that many people have given because it's according to some, this can explain celestial observations well. And the model is that what we call Earth is a circle, effectively, and there's an ice wall around this circle. So we're like a lake. Take what you see on the sphere, put it in 2 dimensions, and at the center of that circular lake is the North Pole. It's both the geographic and the magnetic North Pole. So anywhere you go that's away from the North Pole is magnetic south. And due east or west from the magnetic North Pole takes you in a circular pattern. So circumnavigation, some people would say, oh, Magellan was able to circumnavigate the globe, therefore it's a globe. Well, no, you could explain circumnavigation on a flat Earth too. It's just a circular pattern around the North Pole at the center. If you go due east or west, that doesn't prove flat Earth, doesn't prove sphere. You can explain circumnavigation east-west. And
same thing with Columbus too. Same thing with Columbus, supposedly, like going west and coming east, like it can still be explained on either model.
Either model, you can explain all those things. Just you have to recalibrate where the poles are.
Mm-hmm.
And like I said, this flat Earth model does not have a south pole. The magnetic field is coming from the North Pole, which is, I want to get to this later because it's really critical as we get to the problems with Earth's core. So, okay, so what else is there? There's the motion of the celestial bodies above us. There's the sun and the moon that are much closer and much smaller than we've been told. And arguably, some would say they're roughly the same size. How far away they are and how big they are, I've heard debates, so I don't even want to go there. But the point is, it's not close to what we're told in the heliocentric model. There are lights in the sky, like stars, and they rotate around Polaris, which is the North Star, and that's supposed to be above the North Pole at the center. So again, we're talking about a circular lake that has the oceans and all the bodies of water and the land masses surrounded by an ice wall. The center is the North Pole. Above the North Pole is Polaris, and the stars in the sky rotate around that. And there are planets, and the word planet means
Polaris
wandering
doesn't
star.
Move. Polaris doesn't move. Is that
I've heard 2 different things on this, so I'm not sure. Okay. So I think either some say it doesn't move at all, or it moves a tiny bit.
Mm-hmm.
But that is the center point around which the other celestial bodies move. That's like the general theory. And then there are the wandering stars, the planets, which have movements that are different than the normal stars. And that's why they're called wandering stars. And the belief is, well, Earth is a planet. But what if Earth isn't a planet? It's just the body that's looking at the planets. So there's this presupposition often that Earth is like those other bodies, even though maybe the planets are, Earth is not a planet. It's just a different place. It's a plane. Some would say it's a planet minus the T.
It's a realm, bro. It's a realm.
And then when we get into this notion of perspective, realm. But the notion of perspective is really important too, this azimuthal grid of vision, because it can explain the way stars seem to be moving above us, because some people would say, oh, there's different rotations in the northern and southern hemisphere. How do you explain that? And what the globe skeptics will say is that it has to do with visual perspective, because things in the distance look like they're moving down. They look like they're in front of you. So when you're looking at something that's in front of you that's spinning in a certain direction, that's the direction that you're looking at it. But if you're looking at it from another position on the plane, it's going to be looking like it's spinning in another direction. So often people don't take into account this visual perspective, the dome of vision, which explains also what are called like moon dogs and sun halos, and even the round shape of rainbows. All these visual things that we perceive, you could explain it on a flat Earth using visual perspective. So was that a basic summary?
Yeah,
Joel?
Cool. And let me know, like, because I understand from the flat Earth perspective, like the sun does a smaller, circular rotation for the quote unquote northern hemisphere, then does a wider circular rotation for the quote unquote southern hemisphere, yes, which is really just at the edges of this circular map.
Yes, that's important. So the sun and the moon are making these circular rotations above the circle of the flat Earth plane. And I should add, when I said the ice wall on the outside, that is Antarctica. So in this model, Antarctica is not a continent floating in the ocean. It is an ice wall. And that's why it's so important to explore it, to know whether that's true or not, to explore it fully. So to your question about, you're talking about seasons, Joel, that the sun during the northern hemisphere summer is rotating more closely around the North Pole, which is at the center of the circular lake. And as we move away from the northern hemisphere summer, and northern hemisphere just means closer to the center. So northern and southern really are kind of misnomers, and even their hemisphere is a misnomer. So equator is just a circle of a certain distance away from the northern hemisphere, and the Tropic of Cancer and Capricorn are distances away on both sides of the equator. That's basically what it is. So the sun in the northern hemisphere summer rotating more closely around the North Pole. Then as we move toward northern hemisphere winter, it's making bigger circles because the circumference it has to travel is bigger in the southern hemisphere. And it also moves at a faster speed because we know that there are 24 hours in a day. And if you're moving around a bigger circumference, a bigger circle in the northern hemisphere winter, the sun is going to be traveling faster. So basically, in short, the sun's moving in circles, but it's moving in different types of circles depending on the season, and it's at a different speed. And that explains the flat Earth globe skeptics would say we can explain that because there are differences in the amount of twilight, which would explain why there are different speeds in the sun. And we can also see it based on the analemma shape, which is what the shape that the sun's path takes. If you take a film of the sun's position in the sky at the same day, every day of the year, it makes a figure 8 shape that is asymmetrical. And they would explain the asymmetry not by Earth's tilt on a sphere, but by the fact that the sun is moving faster or slower depending on the season.
Yep. Okay, so based on this map, Australia and New Zealand and South America would be on pretty much opposite sides of this flat Earth map. They wouldn't be closer to each other as they are on a globe map, right? And so, like, we have an 11-hour flight from Auckland to Santiago, Chile. How was that explained in a flat Earth scenario?
Your question is that it shouldn't be 11 hours?
No,
based on that distance?
No, it should be 20 plus hours if it's supposedly on the other side of the Earth.
Based on
so what I've heard people say, is that the scale isn't necessarily correct. Like, so the Gleason map, which is the one that people often point to from like the late 1800s as the flat Earth map, what I've heard people say is that it is not precise. And that's maybe one of the reasons that it's been allowed to propagate, that there might be differences in the actual geographies and then the distances between land masses than we're told. So my answer to you, Joel, is I don't know.
Okay.
But we would have to know what the exact map is first.
How are time zones related to all this?
So this is a big one, at least for me when I was looking at it, because it would seemingly be easy to have just 24 time zones because there's 24 hours in a day. And yet there are 19 time zones in the northern hemisphere and 32 in the southern hemisphere and 24 at the equator, which incidentally, the equator on the sphere is where it most closely aligns with the approximate flat Earth map. And you have 24 time zones there. So what the globe skeptics would say is the reason for these differences in time zones, it's not political differences. It's because you're hiding the real shape of the Earth. And therefore, you have to compress or stretch things out depending on the hemisphere and actually hide time zones. And you end up with an international date line, and you end up with Alaska and Russia being so close to each other geographically, but there's a 3-hour hidden time, and then time zones being hidden in the oceans. And they're very strange things. And I quote a man in the book who is a world-renowned sailor who's now a globe skeptic talking about these time zones. Now, I want to give a related issue that I mentioned in the book of magnetic declination, because this is another one where the flat Earth map most closely aligns with the fewest anomalies where the globe and the flat Earth map are the same versus the other parts. So magnetic declination refers to the differences between the geographic and magnetic poles on the sphere. So on the sphere, the globe model, There's a geographic North Pole and a geographic South Pole that you can point to on the map. But the magnetic North and South poles are not those same locations. They're different, and they actually move around. And the scientists say this happens because our magnetic field of Earth comes from the core of Earth, which, as a reminder, we've never been there. We've only been able to dig down under 8 miles, and the core is supposed to be roughly 4,000 miles. But they say the core is there, and the center of the core couldn't generate a magnetic field because the temperature there, which they've never even experienced, is allegedly exceeding the Curie point, meaning you couldn't generate a magnetic field there. So they say the outer core generates the magnetic field due to the geodynamo effect. The problem is no one has ever replicated the geodynamo effect. And this is problematic because we end up with all kinds of anomalies where the poles are just shifting based on whatever this theory is. And also there are problems with navigation, meaning if you're trying to get from one geography to another using a compass, which is what you do when there's a magnetic field, the compass is going to be based on the North Pole or in the South, these various poles. You don't get to the right location unless you manually adjust the compass. And this is most pronounced in the Southern Hemisphere, where you have to most change the flat Earth map to fit into a sphere. So anyone can do this. Go to magneticdeclination.com and point to different places in Antarctica, and you can see the amount of adjustment that would be needed. In some cases, it's over 170 degrees, meaning that you would have to just literally turn around based on what your compass is reading and go in a different direction. And then a few miles away, the magnetic declination might be like negative 80 degrees. It goes completely haywire in the Southern Hemisphere. But the magnetic declination adjustments for compasses are least pronounced at the equator, which is, again, where the sphere and the flat Earth maps most closely align. But think about how nuts that is. You literally can't get to the right place unless you have a chart that tells you how to change your compass. And instead of saying, no, we got it wrong, we say, no, this is how it works. This is the magnetic field, and it's weird because of a geodynamo effect that we've never proven to be true. And we've never been to the core.
Yeah. It's interesting, when you think about 9/11, there's like architects and engineers for 9/11 truth. Like, are there like pilots and sailors for Earth truth? Like, do you know of any like groups that have come together of these people that are, again, like sailors and pilots that are challenging the globe Earth model?
I haven't heard of organizations because it's such a taboo topic. And it's interesting because I was traveling abroad in May, so like a month after we talked, Yerasimos, and something totally unrelated to flat Earth stuff. This guy sits next to me. He was visiting from abroad too. I was in Europe, and he is a pilot. And initially, we're just like talking about the other books I've written, and he was interested in those topics too. And then I was like, yeah, I've kind of been looking into cosmology. I didn't know I was going to write a book or anything. And he's like, yeah, I was a pilot for over 2 decades, and I used to train other pilots. We definitely don't live on a spinning globe. And I used to train other pilots, and I never taught them to adjust for curvature or motion. And he was explaining something to me about the way his gyroscope, I didn't know the technicals of it, but basically like there were things he could measure that to him suggested that it's a plane. And I thought that was super interesting because this guy spent his career doing it. And then I've talked to other people too and seen testimony from people in various professions where it's super taboo to talk about this. So it seems to be fragmented. And this pilot who I met abroad, he told me that there were a few others that he knew of who also believed that Earth is not a spinning globe, but the others would just always rationalize the anomalies because it was too hard for them to comprehend. And therefore the globe skeptics didn't feel comfortable speaking out as pilots. They would have to quietly acknowledge each other. That's what he told me.
Yeah. Is there a conspiracy around the word plane itself? Why is a plane called a plane? Flying around a potential plane?
I don't know. It could be.
You got to get into the etymology of these words and everything. I don't know.
I mean, plane means flat or level, right?
Who knows?
Who knows?
Interesting. So, okay. On a flat Earth map, you have the sun in the Tropic of Capricorn, circular motion for the Southern Hemisphere. And we're saying Antarctica is an ice wall. And so we have this quote unquote final experiment coming up at the end of this year, where supposedly a group of globe skeptics and globe proponents are going to travel to Antarctica to observe whether there's a 24-hour sun that is visible for 24 hours. And basically the question is that, a 24-hour sun would not be possible on a flat Earth map because at some point the sun's going to be so incredibly far away from where one is standing if they're in Antarctica. Can you speak into this, please?
Yes. So first, we are going to presuppose a flat Earth framework, which could never be comprehensive. So I think that's one of the just fundamental issues. But let's presuppose that the flat Earth framework they talk about is generally the alternative that's out there, where there's this Antarctic ice wall. And yes, in the southern hemisphere summer, the sun would be so far away because it's such a big circle it's traveling that at a certain point, people on one side of Antarctica, the Antarctic ice wall, shouldn't be able to visibly see the sun because it's on the other side. Now, the question is over whether whether there is sun visibility, meaning seeing the sun, or sunlight. There's a distinction. Sunlight would be relevant here because of a phenomenon in physics known as coffee cup caustic, where basically if you shine a light in a dome enclosed thing, which is what the flat Earth model is basically talking about, you end up with this essentially reflection where the light goes around the side. You'd have to see a demonstration of this, but it's a well-known phenomenon. And if the sun is on the other side of the circle, you could have this coffee cup caustic effect where you would see sunlight because of the physics around the edge, but you wouldn't see the sun itself. So this is a good test, Joel, to have people go to the southern hemisphere and during the summer and see and actually film the sky for 24 hours and see, can you see the sun itself for 24 hours? Continuous footage, because some people criticize the government for having cameras there, but then always cutting off the footage for several hours. We want to see continuous 24-hour footage. Is the sun there for 24 hours, or is there a period in which you can't clearly see the sun, but there is sunlight? That is a good test.
Yeah, it's interesting, and I'm curious why. I haven't reached out to these people individually, how certain pretty well-known quote unquote flat earthers or globe skeptics are turning down the opportunity to be flown there for this experiment. Do you have any insights as to why? I don't know if you've been in contact with any of these people, and I'm curious if your book gets more, continues to get more popular, you're going to be getting a phone call from this dude and being like, "Yo, Mark, you want to come down to Antarctica at the end of the year?"
Yeah, good question. I've heard some people talk about it. Number one, there's always questions about who's funding it, and is that person trustworthy, and is that person biased? And is it dangerous to go? And will the filming itself be done in a way that everyone agrees on? I mean, my opinion, based on how much debate there is we need multiple of these quote unquote final experiments. Independent people, like a globe skeptic funding it, a globe proponent funding it, and doing it repeatedly and having multiple cameras in different environmental conditions. Because I could imagine maybe there's some kind of weird haze one day and it's ambiguous. Is that the sun? And everyone's debating, can you actually see it? You need to have a lot of different footage of this to actually do
on a cloudy day you can't. On a cloudy day you can't see the sun.
You're asking.
Oh. Sorry, delay.
Yeah, no. Yeah, on a cloudy day you can't see the sun, and then we get into some really weird things where, that documentary I mentioned by the host of Crow 777 Radio. He's got this advanced telescope. And he shows this thing where he's looking at the sun with his advanced telescope and then moves the telescope over. And there's another round circular body that's also orangish in shape. And you get into questions, are there multiple suns? And ancient mythologies have talked about various things with these luminous bodies, like a time when there wasn't a moon and there were multiple suns and different ideas. So I just throw that in there because if we don't really understand the bodies in the sky, then there might be variables that we're also not accounting for. That we might just have a very fixed model of how the cosmos works, and we're doing this experiment based on that. But what if there are other things that we don't appreciate?
I see how it can be problematic with, flat Earth, because it feels like whenever there's some kind of potential debunk or question mark on flat Earth, oh, well, we just got the flat Earth map wrong, or we just got this part of it wrong, we just got this wrong, and just constantly contorting itself into, whatever becomes falsified within the potential flat Earth model as well, which can become arduous and tiring and all the rest of it,
Totally. Which is why I'm not in the business of proving flat Earth, because I don't think it can be. I'm much more interested in these anomalies that the globe can't explain. And the globe proponents typically don't want to go there. They want to say, no, we can explain things pretty well with heliocentrism. We explain all this stuff in the sky, and we've got a cosmology that works pretty well. But that's where I think we should be going, is to go into the anomalies, and rather than try to fit it all onto a certain alternative, although some people should I think it's a good exercise to do, is to really understand that our current cosmology is wrong.
Yeah.
Yeah. I mean, I think, yeah. I mean, when you think of science, it's like, I think pointing out the flaws, of a hypothesis are important, and at the same time, like, how do we present other alternatives based on new data, and I guess it's like an interesting balance, in terms of like, like I said earlier, there are people that go, well, create a better model, like show us better evidence, or else we're not going to scrap this one just yet.
Yeah. And then the rebuttal is, well, then let us explore Earth freely and privately, no restrictions.
Yeah, I agree.
Right.
I think it's weird that we can't travel there. It's weird to me.
Yeah. Or just dig all the way down, miles and miles down, and show me what's under there. Because you should get to a certain point where you go out of the globe and into space, right?
Yeah. Yeah, but yeah. I'm curious about this final experiment, but again,
I was going to say the same thing. It's very interesting.
I'm curious about this final experiment, but again, you bring up points where there should be multiple final experiments, because like we don't know what the day is going to be like. There could be a cloud in a certain area, like large clouds that are blocking things. And
but this is the other thing. Someone who has so much certainty around flat Earth, no matter what happens, if there's an agreed 24-hour sun view, there's still going to be skepticism, because they just entrench themselves psychologically so deeply in that model. Like, it doesn't matter. It goes for the same with the other side as well.
Yeah. This is dogma on both sides. And then we get into psychology. We get into like whether or not a person has the capacity to like consider, I could be wrong. And then what does that do to their sense of reality, their relationship to themselves, the way they take in information. And so again, like, there is a psychological component to all this as well, but yeah, I'm curious. And
I would also add there's a metaphysical component too, because we're often presupposing that Earth is physical and that matter exists, and that atomism is a real philosophy, that there are subatomic particles and anything is physical. But if we get into the realm of consciousness, then really weird things become possible, where maybe Earth, it's not a fixed thing. It's based on our perception. It's both. Like, I don't know. It's both. I quoted a guy in my book from the secret space program, which I was interested in looking at, going back to your question, Joel, because I had heard people talk about a secret space program. They claimed that they were mind controlled and they were sent on these expeditions in outer space and on planets. And like, I've heard this testimony over and over again. And part of me is skeptical, because they were mind controlled and they could have implanted memories, but almost all of them are globe proponents, secret space program people, which I wanted to just try to reconcile for myself. So I went through and I was like, is there anyone in the secret space program who is a globe skeptic? And I found one guy who was doing an interview saying, like, I think it's way more complicated than sphere or flat. Like, we're dealing with this multidimensional reality. And I quote him in the book, so I'm paraphrasing here, but he says it's an oversimplification to say it's sphere or flat. It's like way more complex because of the nature of reality itself.
Yeah, we've had supposed secret space program, people on before, and he definitely believes it's a globe, which is interesting to note as well. What was I going to say? It kind of escaped me for a second there. Okay, yeah. Okay. The final chapter of your book, I guess, explores this whole concept of idealism and whether matter actually exists or not, and perception is everything. Can you talk a little bit into that? Personally, it's a little bit of a slippery slope to question all of existence, to question objective reality to this extent, right? Because then all of a sudden, okay, fucking, there's no objective truth.
Yeah. So the idea under idealism is that everything literally is consciousness. So what we perceive in the world to be physical is just a manifestation of consciousness, and we're just interpreting things as being physical and out there, but they're not actually that way. One of the reasons that I have been drawn to this is because of the philosophical parsimony, meaning that this philosophy can explain reality as well as other philosophies by invoking the fewest number of assumptions. Meaning, according to Occam's razor, which is that the simplest solution is usually the best, you should prefer idealism. Now, what do I mean by that? If we assume idealism is wrong, and that some form of realism is true, which is that there is a world out there, that there's a world that's out there independent and outside of consciousness, meaning that if all consciousness disappeared right now, the world would go on merrily as if nothing happened. That is an unverifiable belief system because there would be no consciousness to verify that world. So we could never verify a world outside of and independent of consciousness. Whereas a world in which consciousness is fundamental is the only thing that we can verify, because the only thing we could ever verify is our consciousness and that which is experienced within. Now, some people could take that to an extreme. Well, if nothing is actually real, then nothing matters. I think that's a misinterpretation. Idealism can work with meaning. It just means that the reality that we perceive is not physical in any way.
Yeah, but it's also taking the assumption that you know, that if consciousness didn't exist, then nothing would exist. Like there's also that presupposition within that philosophy, right?
Well, it's not presupposing. Well, I guess it is, and it's not perfect for that reason. But it is. It's still taking the only thing that we know, which is consciousness. And so, like Bernardo Kastrup is one of the main philosophers who talks about this. He calls them like ontological categories. Consciousness is an ontological category that we know because it's the only thing that we truly experience. Whereas a world outside of and independent of consciousness is another ontological category that is unknown because no one's ever experienced it. So while idealism is actually not provable, like you say, Joel, it's not perfect. We could come up with scenarios that aren't perfect, but it does a better job than any other philosophy because it starts with an ontological category that we know because we experience consciousness.
So, for example, like under idealism, would the house that I'm currently living in only exist because I'm experiencing it?
Well, the question is, who's I? When you say I as Joel, that would be like using Dr. Kastrup's analogy. You're a whirlpool within a stream of consciousness, where the stream of consciousness, the stream of water, so to speak, is all of reality. So let's say your whirlpool dissolves and stops being a whirlpool, meaning your consciousness doesn't die, it flows back into the broader stream, it transitions. It doesn't mean that the whole stream has disappeared. So I think if you meant I as in Joel, if I as in Joel ceased to exist, would the house still be there? I would say yes, because your whirlpool has just transitioned into a new form. Whereas if you meant as I, the entire stream of consciousness, if that went away, I would say, yes, the house would go away too, because all of reality is a manifestation of that stream of consciousness. So the house is only there because the consciousness that underlies it is there.
Yeah. Okay.
Much to ponder.
Yeah, for sure. Did you want to touch on ether quickly?
Ether in, let's just say, ancient science was known to be the fifth element. And then starting in the late 1800s, ether was basically taken out of modern physics because of interpretations of certain experiments. Most notably, what's known as Airy's failure, but many actually would call it Airy's success because it proved the reality of an ether and it proved a stationary Earth, depending on how you interpret it. And also the Michelson-Morley experiment of 1887, and then subsequent experiments that replicate it. There were many replications. So those studies, let's say Michelson-Morley, was interpreted as Earth moves, obviously, because we know that. And because Earth moves, if there were an ether, we would expect X, Y, and Z. And because Earth moves, we know that to be true. We suppose it. We observed X, Y, and Z, and therefore we tell you the ether doesn't exist. That's a massive simplification, but that's what happened. They presuppose Earth moves, and that for them allowed them to interpret the experiments as getting rid of the ether. And it gets into a lot of technicals as to why that's true. Whereas if they said, well, maybe Earth is stationary, and what we observed in the experiment shows that there was it's called a fringe shift, that would explain it too. So there was an ether that exists and a stationary Earth. Now let's assume that an ether does exist. That gets into all kinds of questions about the nature of reality itself, because the ether could be interpreted as a spiritual interface in a sense. So if all reality is consciousness, ether could be the interface that brings things into apparent matter. So what we call matter could be excitations of this background ether that underlies our reality, or even light. What we call light is just excitations of ether. Movement of light is actually just different parts of the ether lighting up. These are different hypotheses that are out there. A related topic is that of free energy, is that some speculate that we could draw from the ether in ways that I don't fully understand to bring in free energy, which would get rid of the resource constraints. And perhaps Tesla was working with this too. So these cosmological questions, whether it's flat or not, or heliocentrism, geocentrism, it does relate to ether because ether relates to Earth's motion. So if we're going to say Earth is stationary versus not stationary, that has implications for the ether, which has big implications for how we see reality and implications for technology.
Got you. So is ether potentially what the lights in the sky are contained within and is moving around us?
Well, it depends on the interpretation. So I would say that everything, all of reality, or all of physical reality is being underlied by the ether. Mm-hmm. I think of the lights in the sky more as moving through some kind of a medium, whether it's a fluid medium or something like that. Mm-hmm. That's more of the typical hypothesis. But there is an ether drift that many talk about, which can affect the light that we see and perhaps even in the movement. So I don't fully understand how all that works. I think it's related to it, but there could be some other medium too.
Dude, thank you for sharing all that. This just popped in my head because I don't think we touched on it. Can you talk about the Van Allen radiation belt and what that is? Potentially.
So it's this, what it potentially is. Basically, it's this massive amount of radiation that should be difficult to travel through. So if someone's going to the moon, for example, like the Apollo missions, there was a lot of science that said there's a ton of radiation there and it would be difficult to travel through that safely. And there are all kinds of anomalies with the Apollo missions that we haven't talked about, one of which is the fact that they went through these Van Allen radiation belts with technology from the late 60s and 70s. But some would argue, let's say globe skeptics, that what is referred to as the Van Allen radiation belt is really a reference to the firmament. And NASA has, and scientists have basically just distorted all of that to say it's radiation, but it's actually some kind of enclosure to Earth that we don't perceive with our eyes.
So the moon exists beyond the Van Allen radiation belt. So then
does it?
Mostly.
Does it? Yeah, I don't know. I've heard so many different theories on where these lights in the sky exist, whether there are layers to the firmament, that it's within that, whether it's beyond the firmament. I'm not sure because I've heard different theories on it.
Yeah. Currently, where you stand based on your research, would you say that you do not believe that we went to the moon, or that would you take the stance that, like, based on the evidence that we're given so far, there are lots of holes and I can't claim yes or no?
Yeah, I'm so skeptical of the moon missions that I would lean closer to thinking that we didn't land on the moon. And I'll give a few examples. Number one, the sketchiness of NASA. So the telemetry tapes, almost all of them, this is the data from the Apollo missions, are gone. And I quoted an official document. Like, that is just crazy that if human beings went to the moon, all the data's gone. Come on.
Yeah. Also, why haven't we gone back?
Beyond that,
why haven't we gone back?
Why haven't we gone? It's been decades. Why haven't we gone back? And I quote other, like, people from NASA saying, well, we lost the technology, and like very bizarre things. Or that we'd have to solve the Van Allen radiation belt problems before we can go back to the moon, but somehow they solved it decades ago. Many anomalies there, but even the moon itself, if we go to a globe skeptic perspective where the moon is much smaller and much more local, whether it's within the firmament or beyond it, it's much more local. Is it even a physical object? I mean, the traditional heliocentric perspective is the reason when you look up in the sky and you see light from the moon is because it's a reflection from the sun. And somehow we only see one side of the moon because it has to do with, like, the way the moon works relative to Earth. It's very weird. All that's weird. But the globe skeptics would say that the moon is a self-luminous body, meaning it's actually lighting. The light we see is from the moon, not from the sun reflecting off of it. And also that it might not even be a physical place that you could land on. And that's why there have been reports throughout history of people being able to see stars through the dark part of the moon where the moon should be solid. And in the book, I give a bunch of global, I don't even know if I could say the word global anymore, but flags from around the world, where the countries have a crescent moon with a star that's through the dark part of the moon, which makes one wonder if ancient cultures knew that the moon wasn't solid, therefore the whole moon landing narrative of landing on something that couldn't possibly be true.
Mm-hmm. So does the firmament pull into question skepticism around meteors from people that take this perspective?
mean, I think it does. The notion of stuff flying in space and falling on us, is that a correct narrative? Because it really presumes this vacuum of space where things are flying around. And we don't, I mentioned this in the book, shooting stars, we see them above us typically. We don't see them coming from above, from down below the horizon and going upwards. And if we're on a sphere, we should be seeing these celestial events from all different perspectives. And arguably, if you're at different points on the sphere, you should see one person sees a shooting star from one place, another sees it from another. Like it could be looking like it's going up for one person and not for another. But we see these observations from the same place. Usually it's above us moving in a certain shape. But I mean, could things fall from the sky? If we don't understand the firmament, maybe if there's a physical element, could there be things falling? But there also is other stuff like government experimentation that we might mistake for meteors or asteroids or things like that, just things that are falling that are just part of experiments. And in the book, I talk about craters that could be explained by other means. Like we don't see, if there are these huge craters, you might expect, if the crater were created by an asteroid, for example, or a meteor, you'd expect that you would have the physical rock specimen there, at least somewhat intact, and it would be pretty massive and hard to move, but there's nothing to be found anywhere near it. So some have speculated that, like, you can, when geysers are not active, you end up with these geological explosions that create shapes that we would call an asteroid crater, but actually might be a geological explanation. So again, the point here is that a lot of things that we observe in the sky and things that have happened, we're often locked into a model of heliocentrism and a vacuum of space and rocks flying around, and we lock into that to explain the observation, and we don't look into these alternatives.
What are the ways that the potential existence of, infinite space with potential threats and aliens and asteroids, how has that been conspiratorially potentially weaponized against us through Hollywood and media programming and things like that?
Some have speculated that it's all about creating a false flag, that there are aliens coming from distant galaxies that are going to try to take over Earth, like Independence Day is the movie that pops into mind, where there's this nefarious intelligence that's coming here, and we have to unite as a planet to counteract that. And the problem is when you have centralized power wanting to unite everyone and have rules in place, we saw what happened with COVID. Same thing, where you basically end up taking away people's rights in an effort to save us. It's for the greater good that we're going to tell you to restrict your behavior because we're fighting this common enemy. And Werner von Braun, who was one of the leaders of NASA, who also was a Nazi SS officer who came to the United States during Operation Paperclip. So a lot of people often don't realize that there's a Nazi heritage to NASA. But apparently, when he was dying, he told a woman who her interview is available online that there was a psyop basically to try to weaponize space and to weaponize the narrative around it. So I don't know if that's true or not, but I'm definitely more skeptical after COVID that a perceived emergency could be used. And there is much more talk about UFOs these days, but then I worry that it's a multi-pronged psyop. So there's one psyop, which is there's an alien threat, and therefore we're disclosing things because we need to tell you that there's a threat we're going to protect you against. But then we could say there's a psyop there because I think there's reality to these anomalies within the UFOs and contact with non-human intelligence that we shouldn't throw the baby out with the bathwater. There's something there to it. It might just not be the narrative that is going to be, potentially brought to us to try to bring about fear.
Yeah, I'm really curious now with the advances in technology and AI and deep fake videos, like how that's going to be kind of weaponized to support certain narratives, especially around, potential alien invasions, or even just like, oh, we have footage now of being able to see Earth from every single angle. You know what I mean?
Right. How can we verify any of it? It's going to be harder and harder. And then I think people are going to it's going to bifurcate the world more and more. People are going to listen to what they're told by the authorities, or they're just going to believe their own direct experience and not believe other things.
Yeah.
Yeah.
So for you personally as an individual in diving into this research and, considering the implications of geocentrism and flat Earth, etc., how has this affected your individual consciousness?
My first response is that it's led me to feel freer. And I can't explain to you why that's the case. My theory is that if we are living in a deception, about directing the mind away from the deception, away from the falsehood. So it's almost like, in hindsight, I was living my life in more of a lie than I am now, even though I don't think I'm living in the full truth. I was living in much more of a lie, and there's maybe a subconscious stress that a deep part of us feels with that. So I feel like that's been liberated for me. I've also felt like my analytical approach has shifted because of the patterns I've seen with the cosmology debates, which I also saw with virology and germ theory, but they're much more extreme when looking at all of cosmology, because then you have to rethink everything in physics and geophysics, like the Earth. There's so many things that this can be applied to. So I feel like it's sharpened my own thinking in a way that I'm happy about. It's helped me to realize the extent of the deception that we might be living in on this planet. And you guys have covered this extensively in so many different areas on your show. But if cosmology is wrong, if where we live is so wrong, then what does it mean about the forces that have led us to believe these falsehoods? How strong those forces must be, and how deeply embedded in this society they must be, even going back into history. So it's making me question all that even more, human history, which I've always wondered about. But it's like, if we got cosmology wrong and they fooled us on that, how did that structure get in place where we could be so psyoped and socially engineered?
Yeah.
Brother, I'm really enjoying this. I appreciate you. I mean, obviously we've spent some time together, and I just appreciate you and, you know, the world that you come from, and to write 7 books in 6 years or however long it is, 8 years, is pretty incredible. Yeah. What drives you?
I don't know how to explain it. I mean, when I was talking to you, Erasmus, at Confluence in Texas in April, and the flat Earth topic came up, I was saying to you, like, I don't know if I'm going to write another book again. I'd have to find something that really pulls me in. And sure enough, something did. So there's something within me that when I come across something that I feel is so significant, it's almost like I don't have a choice. And especially with this book and the medicine book I wrote before this one, it's happened with all the books, but these two in particular. When I started writing, I wasn't sure I was actually going to have a book. Like, I wrote it. The writing process was going to convince me or not that I had something that was publishable, that I felt comfortable enough with. But something in me had a compulsion to do it. Like, I had to see it through, and I can't tell you what that is. And then when I saw it through, I said, wow, these are compelling arguments that I don't feel like someone who's intellectually honest is going to have a great counter to, because I'm not proposing an alternative definitively. And the anomalies to the current model are so strong and multi-pronged that you have to ask questions. Therefore, I have to publish the book, and I'm going to have to deal with the consequences of it. Unfortunately, I have friends like you guys that are willing to entertain this, and you're open-minded, and you'll ask the questions whether or not you believe it. That's super important, but not everyone's going to do that. And I have to just accept that I might drift away from those other people.
Do you think, based on the topic of this book, like some of the podcast invites are going to maybe be a little less?
We will see. I mean, it's early in the game. Yours is the first podcast that's coming out, I think, on this topic. You guys are the first ones, and I don't usually reach that many people. Yeah, of course. So we'll see. I would imagine there are going to be people that have a hard time with this based on basically the straw man they will create. They might hear clips of me or Instagram posts or something, and they'll write me off and not actually dive in. That often happens with my work, and those people will write me off. But I do think that people who dive in and see the way that I'm approaching it, hopefully they'll stick with me.
Yeah. So this book's been out for a few weeks right now. What has been any of the feedback from any other people, friends or family based on this topic? Obviously, like your last topic also covered pretty taboo, fringy subject as well. But I'm just curious if you've had any initial feedback, or it's still too early.
Yeah, almost no feedback so far on the book. But from the few people who have explored it, I would say generally positive. They're now skeptical of the globe model that's put forth.
Yeah, I mean, listen, I've shared this already. This is not a subject that I've gotten into. People have asked me about it for years. It just wasn't super interested. I wasn't super interested in it. And one reason why is because the few or the several debates that I would see on YouTube just feel like children screaming and yelling at each other and insulting one another. And so it was just like, it didn't really draw me in. you're someone that I have a lot of respect for. I love how you approach information, how you communicate information. And when you told me this was your new book, I was really, really interested and like, got a copy and read it right away. Same thing with Joel. And I have to say I'm way more skeptical and I have more questions than answers, but it's definitely shifted my thinking around this whole subject, which I'm grateful for. Whether or not I come to some conclusion, I'm not going to sit there and die on the hill of my name's Yerasimos and I'm a flat earther and that's it. And all the rest of you are globetards. No, that's not how I operate. But I'm really curious, and I'm curious to see how this is going to unfold and what comes of it.
Yeah, for sure. I think, people that I'm connected to, listeners, people within our community, I think maybe I've been a little bit guilty of being a little bit dogmatic towards the globe without, proper due diligence. I think, especially after reading your book, and I can openly say I'm more skeptical of the mainstream cosmological model, as of right now, for sure.
I am increasingly skeptical. That's where I'd say I am. When I started the research, it was enough to pull me in to say, I'm going to go far enough to try to write a manuscript and maybe publish it, maybe not share with anyone. We'll see. And the writing of the book and the editing process and every little detail that I have to look at, it solidifies things in me that I cannot overcome in terms of trying to rationalize the current cosmology. Like dark matter, dark energy, this is massive stuff.
Yeah.
It's got to be there in order for like gravity and relativity to be the way that they say it is. And that's such a big problem. Magnetic declination. Our compasses don't work and you have to manually adjust them. In the southern hemisphere below the 60th south parallel, which is where we're not allowed to travel, it goes completely haywire. Like these are things that I can't get around. People seeing things that are too far. Like if you wanted to prove the globe, shouldn't you just take a telescope out and show that objects are blocked by the curve over and over and over again? That would end the debate. And I'm looking for that and I'm not seeing it. And I'm seeing the reverse of people being able to see things they shouldn't see all over the world. And they're becoming flat earthers because of what they actually observe with their own eyes. Like those are things that I can't dismiss it. And when there's so many of them together, I'm hyper skeptical of the narrative.
Mm-hmm. For sure. Would you be open to a conversation with a globe proponent on this platform if it wasn't, like character assassinations, attacks, petty insults, etc., like many of these conversations tend to become?
I would be happy to do it, and mostly because it's you guys and your platform, and I know the way that you would conduct the conversation in an effort to try to get to what the truth is. And I've seen debates on other platforms where it's heavily biased and you end up with one person looking bad because they're not allowed to speak properly. I do think it would be helpful to have someone else with me who has been doing this for much longer and who's seen the counter arguments and might just be quicker on certain debate topics. Like Austin Whitsitt has done a ton of these debates. Dave Weiss has done a ton of them, and there are others too. Who I don't know these guys personally. I've had just limited interaction with Dave Weiss, for example. He read my book before it was published. Or even, I don't know, someone like Steve Young. I don't know if he's willing to debate, but he's a theoretical physics PhD and he read my book before it was published. And he's openly talked about a lot of the stuff in his book, A Fool's Wisdom. Mm-hmm. So I would just say it would probably be helpful to have someone else, but I would be willing to do it myself. And I'll just admit where I don't know something. Yeah, there might be some gaps.
Yeah, it'd be interesting to have a rational conversation. Obviously, we've had some roundtables on here that I think have gone really well because, people can communicate in a healthy manner. Yeah, I mean, I don't know Steve Young super well. I'm like halfway through his book right now, and yeah, it's interesting. He definitely takes the axe to a few different I guess sacred cows of the scientific establishment, which is fascinating. And he actually also goes off on Stephen Hawking. So I think you'll enjoy that.
Does he? Oh, okay.
Yeah. He has a whole part of it where he goes off on Stephen Hawking. But yeah, I mean, we'll see what comes of it. I definitely would like to have a conversation, bringing people together, even if it's like 4 people total, in addition to us, so 6 people as well, like it might be an interesting conversation, I don't know. We'll see.
We'll see. Yeah, for sure. Cool, man. I think we've definitely covered a lot. Is there anything that you feel like we haven't touched on, which is important?
He's like, read my book. I got a lot of stuff in there.
No, I think we covered a lot. Nothing else to say.
Yeah, for sure. Loved meeting you recently at Music.
Yeah, I would say this is a book. I'll say this.
Okay.
Yeah, loved meeting you too, both you guys recently. But I do want to say about this book, I wrote it to try to be so it could be a starting point for people. Because most people who are debating the topic, I found, aren't aware of what either side is actually saying. So I tried to lay it out as a like a common ground where we can get to more truth from it. So if members of your audience, maybe this stuff is basic for you and you know it already, I made this book for the friend of yours that has never heard of this stuff.
Yeah.
And so I would appreciate any of your listeners to spread the word for that, because I think it will benefit all of us if we get closer to the truth on this topic.
Yeah. I think it is definitely a powerful introduction to this topic and to understanding the arguments. I think it's written in, very digestible language for sure. And like, I mean, personally, like I recommend it. Like it's non-emotional, which I like. And it, simply questions what rightly needs to be questioned. So congratulations, man. I think you did an amazing job reading this book. It's the first book of yours I've read. And, I'm interested in reading previous books now for sure.
Awesome. Well, thank you, Joel. Thank you, Erasmus. I appreciate you guys supporting me, having me on the platform, and it's just awesome being friends with you.
Yeah, man, I agree. I'm excited for more people to read this book and see what happens. But yeah, other than that, man, just keep doing what you're doing. And I'm looking forward to book number 8.
We'll see.
Yeah, totally. Guys, highly recommend you checking out Mark's work. His books are available, on Amazon. You can also head to his website to learn more, and we'll post all the links in the brief for sure. Mark, man, just to finish what I was saying before, loved meeting you, bro, recently at Music and Sky, getting to hang out, being in each other's energy. You're an awesome dude, and I love the fact that there's like a Princeton graduate diving deep into these topics. Because I feel like that's kind of necessary. Sometimes all this information can come from, people who might be considered more fringe or, a little less quote unquote credible from a mainstream perspective. But, I think having you questioning these things based on your history is really important to the canon. So I think that's awesome as well. And yeah, everyone else, thank you so much for listening. We appreciate it, and we'll see you next time.
What's up, everyone? Hopefully you enjoyed that episode. I just want to really highlight too, like, regardless of where we live and what this realm is, whether it's a sphere, whether it's flat, whether it's a fucking triangle, your life is going to go on. There's things that you have to do. You have dreams, you have desires. There's areas in your life where maybe you've come to the realization that, like, you're not living up to your potential. Maybe you're not doing work that is aligned with a deeper purpose that a part of you believes, you should have. Maybe your relationships aren't as conscious and healthy as you want them to be. And maybe you're just not as content and fulfilled with who you are in this life. And so we have Rise Above the Herd. This is the 11th time we're running this program. Enrollment starts on the 24th. So go to riseabovetheherd.co. And if what you read interests you and inspires you, apply, and we'd love to go on this journey with you.
Yeah. All right, guys. Thanks for listening. Thanks for supporting what we do. Highly appreciate it. And yeah, thanks for being part of our world and for entertaining these conversations. Because we just started this podcast, over 200 episodes ago now, not knowing where it would lead, but we decided to embark on a path and be consistent in our mission. And it's just awesome to reflect back on that and see where we are and how far we've come. And, really grateful for as many of you that are here still listening and growing in numbers and receiving value from these conversations as well. And so, yeah, like Erasmus mentioned, if you want to take the next step, then yeah, riseabovetheherd.co. It's a 10-week private group coaching container with us for you to live your fullest life. Take care.
Smoking mirrors, I'm seeing through the illusion. Waking up in a time they think you're in a delusion. Somebody set the alarms, cause they be too busy snoozing. I'm in a DeLorean, fast forward in evolution.